We started the second lecture on static electricity chapter, and there are multiple things that static electricity can help us do. Let me show you some example for those. Static electricity. No. Hmm. Usesটা গেল কোথায়? Oof. I see. All right. So I'm going to share with the PDF anyway, but let's have a look from these figures and try to understand what is happening. Use of static electricity, we have a couple of examples for this thing, and all of those examples are covered here. These images were taken from the RSIGCC book because these figures are really clear. The original book had color figures, but because I converted it into for the monochrome printing, so that's why it's only black and white. The first thing that we have over here is electrostatic paint spraying or spray painting. You can use this gerund in any of these nouns. What it does is that whenever we are trying to paint complex structures, like for example, this is a bicycle frame, and it is not a regular structure like a flat surface. I mean, painting can be done in a lot of different ways. One of the ways to do painting is by using a brush. The one of the problem of a brush painting is that we cannot paint with a brush with uniform thickness, because every single time the bristles are there, you're going to have a little bit of low thickness, and in the for the in between gap of the bristles, the paint that is left on the surface would be slightly thicker. So brush painting cannot ensure for you to have a perfectly uniform thickness, and it's also actually quite slow compared to spray painting. The second thing that we can do is spray painting. In the process of spray painting, we actually have some liquid paint within a pressurized canister. We use compressed air that is connected to the container that applies some significant pressure on the liquid, and then we can press the nozzle, and the paint droplets are going to come out in small droplet forms, and that can essentially get stuck on a surface. Now, regular spray painting, which is not electrostatic spray painting, can be effectively used for the purpose of flat surfaces like a door, or like a refrigerator panel where you don't have any holes, much of holes, because all you're aiming the paint towards that surface, and all the paint droplets have a pretty much going in a single direction, and the paint droplets can pretty easily get stuck on there. It's a pretty effective process. But if we are trying to spray paint complex structures like a bicycle frame or other type of things which has where we want to have a uniform thickness of paint for the case of beauty and looks so that it looks good, and also that we want to do it with less wastage and also to do it pretty fast, we take help for the static electricity. The way this whole thing works is that you can see over here that this glass frame is hanged by a rod over here. This is usually a metal rod, and the glass frame is essentially made from metal. Other than metal, it will not work. This part is connected to the negative end of a certain DC supply, battery maybe, and the nozzle of the canister is connected to the positive end of the DC supply. What happens whenever the paint molecules or paint droplets pass through the nozzle, because the nozzle is positively charged, the paint droplets lose some of the electron to that positively charged nozzle. This causes all the paint droplets which are coming out to become individually positively charged, because all of them have some positive charge that they gained from the nozzle by losing some of their electrons, because the nozzle is positively charged, being connected to the positive end of a battery or a DC source. So this help us in two different ways. The first thing is that because these two objects are oppositely charged, naturally the negatively charged metal frame will attract the positively charged paint droplets very strongly, and as a result, most of the paint droplets are more than regular. I mean, a significantly larger number of paint droplets are gonna grab around the frame because of electrostatic attraction, and they're gonna get stuck over there, and you are gonna have less wastage because the attraction of the positive and opposite charges is gonna cause the paint droplets to bend towards the metal frame of the bicycle carcass. So that helps for less wastage and a much faster painting process, and also ensures a pretty uniform thickness, because if you are not doing electrostatic spray painting, only the front hemispherical region or only the front cylindrical part would be painted. Nothing behind the surface would be painted. And then to make sure that you would have to paint behind them, you would have to paint it on the other side once again. And where the joint would happen, you would have a bit of less thickness of paint. Whereas for the electrostatic spray paint, you can spray it from pretty far away distance. You're making sure because of the opposite charges, paint droplets are naturally going to get attracted to it, and you can pretty much have a almost uniform thickness if we are careful for this part. That's one advantage, that we can reduce the wastage and we can make the paint thickness more uniform. That's one advantage. The second advantage that we have is that because all the paint droplets themselves are positively charged, they themselves will repel each other. Try to understand this. If the nozzle was not positive charge, if you are not doing electrostatic spray painting, if you are only doing spray painting, not with the help of static electricity, then if you are not doing electrostatic spray painting, if you are only doing spray painting, in that case, the paint droplets would be spread out with a certain angle, and you would get a certain conical shape coming out of the nozzle. I mean, you all know how a nozzle works. I mean, for any type of body spray or air freshener or aerosol, if you press the nozzle, a conical shape of spray comes out. Because now the paint droplets themselves are all positively charged, they are all charged in like charges, they will repel each other. As a result, the spray would have a much wider spread out compared to regular spray painting. The electricity spray painting, the nozzle conical shape or the area of coverage for the same amount of spray paint would become much larger. You might wonder, wouldn't this cause us to lose more paint? The answer is essentially no, because we can pretty much control how far apart the nozzle should be from the frame body. I mean, if you take it closer, you would have a smaller cone attacking the metal frame. If you take it a bit farther, then you have a larger angle of cone. Hold on just a second. So if you are not using electrostatic spray painting, in that case the nozzle cone size would have been much more smaller. So these are the two advantages of electrostatic spray painting. We can do it more uniform thickness and less wastage, and also the paint droplets which are coming out of the nozzle are going to spread out more because of in between repulsion forces. Practically, you are asked about the advantages of electrostatic spray painting and also the inherent underlying principle, physics-based principle, that why is this better compared to regular spray painting. in the first place. So that's all you have to say. If you wonder that is it essential that the metal frame has to be negatively charged and the nozzle spray nozzle has to be positively charged, I mean, does it have to be like this, or is it going to be a problem if we flip the charges? For example, if we connect the metal frame with a positive charge and connect the metal nozzle of the spray can with the negative charges, is this going to make any problem? The answer is a no. Already you have to make sure that you are connecting the two things in two opposite charges, so that pretty much does the job. And then we have the concept of inkjet printers. But before I get into this, anyone has any question about the electricity spray painting? Anyone? Questions?
So
Sir,
can you repeat
Yes.
the part?
I
Yeah,
had a question.
about
Before the paint was sprayed onto the object, was the paint like neutral at in its natural state?
yes, within the container, the paint is considered to be neutral. The this bottle can be made from a plastic container, or can be made from ceramic, anything, but the nozzle is essentially made from a metal head, which is connected to the opposite charge container compared to the charge of the frame. So as the nozzle, as the paint droplets pass through the nozzle, within this passage, they become oppositely charged.
Yes, sir.
So can you repeat the part of the shape of the nozzle?
The shape.
Yes, sir.
Yeah, the shape part is pretty simple. If I draw over here, might make better sense. Let's say this is our container. Oops, this is the container head. Let's say this is the container, and this is the nozzle. If we do not use the charge thing, maybe let's say the not paint. Let's say I'm drawing it with blue. Makes an angle of this much. This is the angle of spread for spraying without the use of static electricity, where the positive end is not connected. But the moment we connect it to the positive terminal of a certain DC source, battery or DC source, then those paint droplets themselves will become positively charged. So essentially, they would tend to spread out more. I'm using red to show you the difference. So the angle of spread would become more naturally, irrespective of the design or anything, because the paint droplets, as they will be moving out from this place, they will repel each other. So you'll have a wider spray area. Make sense?
Yes, sir, I got it.
Beautiful.
So I had another question.
Yes.
After the metal frame was neutralized, if we put on excess paint, what would happen to that extra paint? Like would it drop down or something?
Well, the entire idea of having a spray painting process is that we do not ever want to add extra paint than what we want. First of all, we do, I mean, this paint that we are trying to do over here, first of all, is considered to be pretty costly per gram compared to regular brush painting materials, because these are paint which is expected to last on the metal surface for a really long time over a very harsh use. It's a bicycle frame, so you can pretty much expect all sorts of rugged uses for this material. So we do not want to do that. And how do we prevent that? In the first place, that we prevent it by rotating this frame and maybe also rotating the nozzle spray in different locations, which can be programmed by a computer or by done by experienced painting people. They have to wear proper goggles so that they don't inhale those charged particles. But we do not ever do over painting on in a spray painting process. The entire idea of spray painting is that we're going to essentially apply the exact amount of paint required for the object, and while maintaining an uniform thickness everywhere. But to answer your question, if we ever do paint it over, let's say we are supposed to apply one spray in a certain location, and let's say we apply 10 spray over here, obviously there will be more paint accumulated over there, and then at that point the paint will essentially start to drip down. But dripping down essentially means that within that drip you have a much thicker thickness, much bigger thickness compared to everywhere else, which is not expected out of a spray painting process.
Okay, sir.
বুঝা গেছে?
Yes, sir.
Beautiful. The next thing that we have is an inkjet printer. This inkjet printer is the essentially doesn't, this thing doesn't look anything like an inkjet printer. I'm just gonna explain how this inkjet printer works. Let me just start from the beginning and then slowly talk to you about it. An inkjet printer. Do you guys understand that there are different type of printers? One of the variation of printing process is an inkjet printer. How does an inkjet printer works? That's what I'm trying to show you. This is one of the most common inkjet printers. If you think that Canon Pixma IP 2772, 2772, 2770. These are all inkjet printers. Now, inkjet printer cartridge, they look a bit different. This is how the inkjet printer cartridges look like. If you have a look over here, you can see these are the parts. These are the electrical connection parts. I mean, here you can see a much better view, I think. Oh, no, 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 no.
I've got a question that's deceptively complex. How does printer ink?
No, 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 no. We don't want to see. Okay, anyway, I'll use this figure anyway. What I want you to see over here carefully is that you should see that this is the red marking, which means this is supposed to be on top, so that people can see that this is the container which contains the magenta color. These are the electrical connection points. So all of these metal dots you can see, these are the electrical connection points which should be connected with the circuit when you install the cartridge in the printer. And so this side and this side are the same. You can see this dotted mark, and here we have this rib kind of structures. This is the part where the actual mechanism for how the inkjet printer works. So if we magnify within here, like a really high magnification, we're gonna see somewhat like this. This is a highly simplified figure of the whole thing. So the way, I mean, where does this thing exist? Let me just show you the position where this thing exists. Let's say this is the printer box, large printer box, and the paper is supposed to run through this hole. So this is the phase view, so which means, let's say we're gonna feed the paper from the top. We're gonna feed the paper from the top, and the paper is gonna run through the machine, and then it's gonna come out through this passage. So I'm drawing an arrow that like this shape to give you an idea that this is coming out horizontally. And the cartridge is usually placed on a rail somewhere over here. It doesn't have to be a single cartridge. It can be a set of cartridges if you have different, if you are trying to paint color pictures. And these cartridges spray their paint onto the paper in this motion as they move, and also the paper also moves. So there is a very keen coordination of movement. And this is from this point the ink droplets come out. So if we zoom in over here, like a really high amount, we're gonna see that if there is one of the paint nozzles, if here, actually, let me just take a bit more bigger circle, maybe this might actually help us. Let's say we are looking down over here, and if you take a high zoom over here, let's say this is the paint nozzle through which the nozzle is designed in such a way, and the flow of ink is controlled in a very precise manner, so that it will always give us exactly equal amount of paint, which means the droplets that this nozzle is gonna make, this is a highly magnified nozzle. So this is a, you can say this is a microscopic nozzle. This nozzle is gonna produce, let's say 0.001 gram size paint drop. For every single drop it's gonna make, this is the amount of paint drop. If you want to make more paint on the same location, it's gonna drop more ink droplets, but all of them would have the same size. The mass of each of these paint droplet is exactly precisely equal, and the machine through its circuitry and its motors can control exactly how many droplets it want to release at any given time on any specific location on the page. So this is the container where the inks are kept, and the nozzle is producing a fixed size of paint droplet. As the droplet comes out, we have two metal plates placed beside it. So these two are metal plates, and we can charge this metal plate from the circuit of the device, from the circuit of the printer, as we want. We can apply any type of voltage. You can apply positive and negative voltage. You can apply negative and positive voltage. You can keep them neutral. So, and how much voltage do you want to apply? We can choose it by the circuitry. That's basically what is delivered from these points. Each of these connection point practically controls the exact voltage applied to the two metal plates that is placed on the two sides of one of the nozzles. The way it works, this nozzle, which is the tip at least has to be a metallic nozzle. This is connected to a certain negative voltage. So let's say, let me use blue for the connection wire maybe. So let's say this is connected to a certain negative voltage. So I'm going to give a minus sign over here. If you wonder where does the single minus voltage come from, it's very easy to produce a negative voltage source within a device with a ARC connection. You haven't read about AC to DC conversion or how the electronics work. But for the sake of understanding, let's consider that this nozzle is always connected to a fixed negative voltage, and this is a constant voltage. You don't have to understand, you don't have to know all of these parts, you just have to know how it works. I'm telling you this in a much more detailed version so that you can visualize it better, so that you can understand it better, and you are able to answer questions from these examples at a much more deeper level if required. So this is kept at a constant voltage. Constant voltage means that every single time one of these ink droplets are going to come out, they're going to always come up with a fixed amount of charge. Let's say if one ink droplet comes out with, let's say, minus losing 10, taking 10 electrons, each of the ink droplets which are going to come out of this hole, they're all going to take 10 ink droplets. So one thing we're trying to make sure, as the ink droplets come out of the nozzle, all of them has the same mass, or all of them have the same size. Shape is essentially circular, spherical. And also by keeping the voltage constant, we're also making sure that all of them are charged by the exact same amount. You might wonder, why is that necessary? Why do we have to do that? Because we're going to control the movement of this ink droplet by controlling the voltage across these two metal plates. So this is a metal plate connection, this is another metal plate connection, and underneath over here in a very highly magnified version, let's say this is a piece of paper. I'm drawing this piece of paper like a block because this is highly magnified, so this is the thickness of the paper. So I might as well give break sense over here. Paper is actually pretty big. Exactly where do we want to drop the droplet? This is controlled by the voltage of these two plates. If we do not apply any voltage, if the machine circuit does not apply any voltage onto these two plates, this is going to simply fall due to gravity, and it's going to directly fall on the very underneath point. This is going to drop exactly over here. Now, if we apply a little bit of positive charge over here and a little bit of negative charge over here, then you should understand that opposite charges repel and opposite charges attract and like charges repel. So this ink droplet is gonna bend a little bit as long as it travels through the spark, and it might as well drop somewhere over here. The gravity is pulling it down, but by applying this electric field, we are actually trying to move it to one direction. If we apply a much bigger voltage, then the bend would be even more. It would be even stronger, so it can fall further away. If we apply opposite voltage, for example, let's say if we apply this one to be negatively charged and the other one to be positively charged, you have to understand that this reversal of charge would not have a simultaneously. I mean, one metal plate cannot be simultaneously positive and negative charge. For every single instance of dropping one droplet, these two plates will be charged at a specific value from the circuit of the printer. So they will be either positively charged, negatively charged, or they might be neutral, or they'll be negative and positive charge. They'll be more negative or more positive, but you cannot have simultaneous presence of positive and negative in a single plate. That's not going to happen. So I'm trying to use different color to give you an idea that this is going to happen individually differently at different time frames. So if we charge it oppositely, then it's possible that we can bend the ink droplet on the opposite direction. So it's going to fall onto a certain location. Important for you to understand that exactly where this ink droplet is going to drop is dependent on multiple factors. Number one, how much is the weight of this drop, so that it essentially tells us how much time does it take to fall from the output level of the nozzle to the paper level. Because it's going to fall due to gravity. That time requirement is not essentially dependent upon the mass. It's basically a half GT square. So it's going to fall down over here. So that gives us some amount of time information. This ink droplet is going to travel for this much space under the effect of an electric field, because this is where the electric field is created. So it's going to experience the lateral force or horizontal force, bending force within this part, and as it comes out of the electric field, that force is gone. So you have to pretty much precisely control the charge amount on this droplet and also the mass of the droplet, so that you can actually control how much is going to bend, because a heavier mass would have less acceleration, a smaller mass would have a higher acceleration. So if you produce different size or different mass droplets, you're going to have a mess over here. I mean, you cannot place all the points in a specific location. So we're keeping these two constant. Also, by controlling the voltage on these two plates, you can pinpoint or exactly locate exactly where on the page this ink droplet is going to drop. And that comes through a lot of constraints. Keeping the ink droplet mass same for every droplet, keeping the charge of the ink droplet same for every droplet, and controlling the charge on these two opposite plates very precisely, so that the ink droplet is bent by a very specific amount and ultimately drops on the page on a very specific location. By controlling where they are going to be dropped, we can pretty well produce a large amount of picture. For example, let's see, if we want to print the letter T in a piece of paper, we just know that we have to put ink droplets along these lines. But if your T is a bit thicker, let's say if your T is a bit thicker, let's say if it's like that, we simply have to drop more ink droplets over side to side, and that's what these inkjet printers are going to do. So by placing multiple dots one after another, you can actually make letters and eventually all the shapes that you want to print from a printer. One of the key important point for the inkjet printers is what you call DPI. I don't know if any of you have come across this term. This is a very important information for an inkjet printer. DPI stands for dots per inch. Dots per inch. It means how many drops, individual drops, can the printer make within a 1 inch length. So if you have a printer that is let's say 600 DPI, if you have a printer that has 600 DPI, it means within a length of let's say 1 inch space, it has 600 individual drop locations.
Sir.
Yes.
Sir, এই ডিপিআইটা স্যার মাঝে মাঝে মাউসের উপর লেখা থাকে স্যার।
হ্যাঁ, ওটাও বলতেছি। If you have 1200 DPIs, this means that you can have 1200 individual location located by the control of the printer. Some printers can have this DPI that can be varied, because if you have a higher DPI, the printer circuit has to do more calculation and it has to be more precise in its performance. So your printing time, the amount of time it takes for one page to go in and come out on the other side being printed, that is going to be more. If you try to print a picture at a higher DPI, you're going to get a much better resolution and good looking picture, but it's definitely going to cost you a bit more time. But if you have a lower DPI, it's going to print much more faster, because you are going to have big size drops. So you're going to require fewer drops to come in. You do understand that in this case, you simply have double number of dots. So you have to control the motion of 1200 dots over here. In this case, you have to control only 600 dots over here. So it's basically like the pixel size cause sort of equal comparison for what happens for a photograph. If you have a large pixel, then your picture seems to be breaking apart. You just যেটাকে আমরা বাংলা বলি ফেটে যাওয়া। একটা picture যদি আমরা অনেক বেশি zoom করি, at one point it starts to crack up. So that's what happens when your pixel size is too big, or in this case the dot size is too big. So that's basically how the inkjet printer works. And you have to understand that when a inkjet printer actually works, this nozzle actually moves pretty fast, and the paper also rolls out pretty fast as well. So the calculation that how fast this both of these things, the ink cartridge and also the paper is moving, how often the droplets are made, and how precisely the voltage of these two plates are maintained, is of very superior technological achievement. In my opinion, it is. We don't see it because we just click the button print in the mouse and we see page coming out. But what physically happens within is, in my opinion, mesmerizing. Did it make sense? Any question?
I had a question.
Yes.
So when the ink drop falls to the plate, why doesn't manufacturer design in such a way that it only repels from the unattractive force? Like, why does there have to be two charges? Why doesn't it just repel from one force? Wouldn't that also decrease the energy consumption?
Yeah, that can be also done. That can be also done in which case, I totally agree with your point. In many printers, that is also an adapted design. In many cases, this is also adapted design, means that in many printer we can also have, let me use black for this one, that we can keep one of the plate to be always connected to a ground connection, which will always be 0 volt, and the other plate will be controlled by positive or negative. The benefit of having both of the plates being able to charge in maybe opposite charges is that you can achieve a much more stronger field. What I want you to understand, that let's say if you have two plates facing each other by a single distance, one is at 0 volt, the other one is at +6 volt, the amount of electric field strength that you're going to get over here, compared to that, if you have in another case where you have one plate over here and equidistant another plate over here, this one is at -6 volt, while this one is at +6 volt, you can see that over here the voltage difference is 12 volt. So over here the field is going to be even more concentrated, right?
Yes, sir.
It's going to be much more stronger field. So the benefit is that this can help you achieve to make more bend on the two sides. Now, if you can, try to understand, let's say this is a piece of paper. If you have this thing, maybe you have one cartridge over here. Using that cartridge, you can only cover the vertical drop and the towards side movement, because the ink droplets are negatively charged, right? The ink droplets are negatively charged. So using a neutral plate, you cannot actually move it to the left. Using a positive plate, you can only move it to the right. Am I correct? বুঝতেছো কি বলছি?
Yes, sir.
If we apply more positive voltage, you can bend it further. If we have low positive voltage, you can move it less further, but you can only move it in one direction. Whereas if we have both the opposite charges, it is possible for us to achieve that the ink droplet might be able to bend in both directions. So if you have both direction, you are going to require fewer number of nozzles to cover the entire page. But if you have only this much space, you're going to need more nozzle numbers. You have to have more nozzles, right?
Yes, sir.
So that essentially is a design consideration which makes the manufacturing and also the cost significantly less.
Right, sir.
What you proposed is perfectly workable, but having both the plates chargeable has its own default advantage. That's all I'm saying. But what you propose can work perfectly, no big deal. I mean, no fault there. Any further question?
Sir,
Yes.
why do we need to control the voltage of the droplet?
Not the voltage of the nozzle.
Yes, sir, sorry, nozzle.
Because if all the droplets are not having the exact same charge, then a bigger negative charge would be affected more strongly by the same field. Let's say at one point, let's say you want to draw a line. Let's say this is a printer nozzle. Try to understand, this is the face view. So try to assume that this page is extended out of your screen. I mean, this is a page that is going into the page and out of the page. This is a flat page. This is the thickness. If you want to draw a line in this location, let's say you want to draw a line exactly in this location, you want to draw a vertical line. So which means if you look on this paper from the top, this paper is supposed to look like this. Here is the paper and we want to draw only a vertical line over. I'm giving an example of vertical line to make sense. To make a single straight line stained vertical line, we should logically have the same voltage across these two plates for the entire printing process, right?
Yes,
Because
sir.
now, if these droplets do not have same charge, then the one that is more charged will be repelled more to the left. The one that is less charged will be repelled less to the left. So you're not going to have a straight line. What you're going to have is a zigzag line of droplets. I mean, more charged particles are going to bend more, less charged particles are going to bend less. So we cannot have precise location. বুঝছো কি বলছি?
Yes, sir.
Clear হয়েছে?
Sir, thank you.
Sure, no problem. All right, so this was for the inkjet printers, and the third thing that we have over here is photocopiers. Photocopiers is actually a series of things which can work. And if you see over here, this is the number 1 figure and it goes on in an anti-clockwise cyclic order. I'm going to explain this thing part by part. You can read it about this. Let me just explain what is happening. Any photocopier or a laser printer for that matters, they pretty much work in the same principle. The difference between a photocopier and an inkjet printer, there are actually a lot of differences, but one of the differences between an inkjet printer and a photocopier or a laser printer is that photocopiers and laser printers use powder ink, whereas inkjet printers use liquid ink. The way it works is this. In every photocopier, we have a drum, uniform cylindrical object, which is called a drum, that is coated with a very special element called selenium. Now, selenium is such a material. It has a significant amount of photoelectric property. Photoelectric property is basically the property of a material by which it can produce electrons when light shines upon it. That's the idea of photoelectric material. So selenium happens to be such a material that whenever light falls onto a selenium atom, it can produce electrons out of itself. Try to understand. Whenever light falls onto selenium, it can produce electron out of itself. And then again, selenium is not as good of a conductor like the typical conductors that we know, like iron, copper, nickel, cobalt, these things are pretty good conductor, but selenium happens to be within the borderline of metal and non-metals. We call it what do you call those materials which is on the borderline of metal and non-metal?
Metalloids.
Metalloids. Yeah, metalloids sounds like a good idea. What are mu metals? Have you guys ever heard this term, mu metal? Mu metal.
No, sir.
Okay, never mind. So selenium happens to be one of the in the metalloid region. Mane, the reason I'm telling you that selenium is not a very good conductor of electricity. So if it produces charge at a certain location, it pretty much can hold charge over there, and it's not gonna cause a discharging effect over its whole self like a regular metal that we know, like an iron piece, aluminum piece, or a copper piece. I mean, if you allow the charges to move that is built within these metals, this charge is gonna be distributed all over the material, be it a sheet, be cube, wire, cylinder, doesn't matter. But that's not the case for selenium. Selenium works in such a way that if charge is produced in a location, it pretty much stays there, pretty much like non-metallic substances. At the same time, it has an additional capability that it can produce electron whenever light shines upon it. So if light doesn't shine upon it, it will not produce electron. If light does shine upon it, it will produce electron. So try to understand, visualize a cylindrical object, which is let's say a cylindrical a cylindrical thing, can be solid, can be hollow, depends upon the design of the device. But anyway, let's say that that cylindrical object is perfectly coated with selenium. It is perfectly coated, it means covered with selenium. So that's this thing, a perfectly cylindrical object which is coated with selenium, is essentially what we call the drum of the photocopier machine. So from this point onwards, I'm going to use the word drum continuously, and I want all of you to listen carefully. The first step, you can see that over here, the first step, number one, it's let me zoom in a little bit maybe. Okay, the first thing it says that drum is charged here. The way we charge the drum is that we apply a positivity charged airflow onto a certain thickness of the drum. So if I just try to show it to you in a bit of a diagram process, let's say this is the drum. I'm trying to show you in a bit 3D view. And let's say in front of this drum, we have a horizontal nozzle of air pathway. So what I want you to understand that this is actually a passageway from which air is coming in and is hitting on the nozzle for the exact face part. And this nozzle is rotating in this orientation. And all the air particles that we are sending, they are all positively charged. If you wonder how did you get the positively charged, it's very simple. It's very much similar like the nozzle that we have seen for the electrolysis spray painting. That we are flowing in air through this hole, through this channel, and this metal piece is connected to a certain positive end of a battery or a supply. This is supply. Now, when this will happen, a certain thickness of the selenium coating would become positively charged, because as the positively charged air particles are gonna go ahead and hit on the selenium atoms, the seleniums are gonna give out their electron pretty easily. And as the selenium gives out their electron pretty easily, they themselves become negatively charged. Sorry, they themselves become positively charged by losing an electron. What is really important, what I want you to understand, that as the selenium suddenly, as the entire selenium of the thickness become charged, all of the selenium atoms are currently at positive charge. So did I just say electrons are in positive charge? My bad. All the selenium atoms are in somewhat positive charge. Now, the coating I mean, now we're going to rotate this thing a little bit, and then we're going to shine some light onto the selenium disk using the paper that we want to print. So have a look over here. Number 2 says, image of the object to be copied, it formed here. Charge stays only where image is dark. So the way it works is that, let's say this is the cylinder. Let me draw you a flat view of the cylinder. Let's say this is the cylinder. This is the side view of the cylinder. Why am I not getting a circle? Good. This is the side view of the cylinder. Let's say this is the side view. It means the cylinder is long. Let's say over here, we are applying the positive charge airflow over here. So positive air. So from this point onwards, as the cylinder rotates anti-clockwise, all the parts which will be going up would have uniform thickness of positively charged material. So if I try to show you this in a three-dimensional view, let's say this is the selenium piece, and we're flowing air over here over thickness of this much. So this much thickness of selenium coating is always becoming positively charged, and this thing is rotating on the left, and we are continuously flowing in the air. We're continuously flowing in the air, and that air is continuously making the selenium coating uniformly positively charged. That's the first thing. The second thing is that as we are going to rotate over here, we're going to apply a very bright image of what we want to print. In this case, for the sake of simplicity, they chose T. So let's say if we want to play T. So if you're trying to plot, if you're trying to print a T, we're gonna place this object which we want to photocopy over here, and we're gonna shine some light over here. So this is the light source, and this light source is essentially barricaded from these toner materials. So this light is gonna travel over here, and ultimately it can go into gel, but we don't want that to happen. So what I would like to propose that this thing, which thing? What did I just say? বলুন আমার কথা কি শুনতেছো?
Yes, sir.
Yes, sir.
আচ্ছা, so as the light will be sent, all the light will not fall over here, but some light will essentially get reflected off the paper and eventually fall onto the selenium coating. This is essentially what we're interested about. It is control. If this is a light source and there is a barrier over here, so that this light source does not directly illuminate the selenium drum, because that would be entirely fruitless, no benefit. There is a small bit of aperture. Aperture basically means the hole through which a little bit of light can pass through. For those of you who have some interest in your in photography, you kids know what the aperture is. Aperture is basically the hole that allows the external light to get inside to কিসের definition বলছিলাম জানো? Aperture is the smallest hole by which a very small amount of light can pass through. So over here, we actually do maintain a significant aperture, so that a very thin ray of light will essentially go over here and bounce off from here, leading up to this location. Now, as this light will fall over here, this page had T printed in it. Capital T is printed on it. So locations reflections coming in from here, in all the places where we have white, from those locations, the reaction would be pretty small. But in places where we have the T material available, so those locations, that T existing over here would essentially absorb the electromagnetic spectrum, because why? The empty spaces are going to be filled up with fluorescent coating. Why?
Sir, এই পার্টটা ক্লিয়ার হচ্ছে না।
আচ্ছা ঠিক আছে, আমি বলতেছি তোমাদেরকে, জাস্ট সেকেন্ড, আবার বলতেছি। Here we are applying some positive air, so this part of this thickness of the drum is all positively charged, and then we are rolling it a bit further, and by using a small bit of aperture, we are sending in some bright light on the piece of paper that we want to photocopy. Reflection of a small portion of the paper is reflected back onto this thing. As this roller is going to rotate, this paper is going to be also move to the left. Either we can move the paper, or we can make the whole device move to the right. It can work either way, but bottom line to understand that as the paper, this is the printable paper, as the paper is shine light upon places where we have printed materials, we have black ink or green ink or blue ink, those locations are going to absorb the light strongly and wouldn't do much reflection. But places where we do not have those things, we're going to have what? More reflection. White locations of the paper are going to do more reflection, and those strong reflections are going to fall onto this piece of paper, and eventually for those strong light, the selenium atom or atoms will produce free electron. and that free electron will neutralize the remaining charges onto the drum for this section. So which brings us to the next point, is that we are going to send the light instruction. If you see over here, I'm not sure if it's really visible. You can see that there are some dark plus signs over here. Do you see that?
Yes, sir.
The reason we have this is because we are trying to print a T, and while the T was this paper T was scanned, in those locations of the T we had black color, so the reflection was very weak, and it did not produce any glow. Whereas the locations where this where we have a little bit of white, those locations produce pretty good results. এরপর আমরা যে কাজটা করব, we're going to spray, এই যে এখানে হচ্ছে নাম্বার 1 2 3, toner drops onto the drum and sticks to charge area. This is something that they have shown over here, but I mean, I'll tell you why it looks like this. This is actually what they're trying to show you over here in step number 3, is that the toner material, the coating over here, become charged for locations it did not receive the light. Locations where it did receive the light, it produces its own electron and neutralizes itself. Now you might wonder, how is it even possible that a certain object produces electron? I mean, is electron a producible thing? The answer is yes. The answer is yes. So as the roller is going to be rotated, we're going to spray some we're going to have this oppositely this shape of positive charge onto this surface. Now somewhere over here, let me draw with a different color, maybe black. Somewhere over here we have another nozzle which is going to spray was it positively charged or negatively charged? Positively charged. So it's going to spray some ink or powdered ink, which is called the toner, onto this location. So there is no charge over here. This is just a delivery system of toner, which is basically per month. So it is going to work in this manner, and the toner is going to get attached to the locations where the drum is still positively charged. So what is going to happen? We're going to get a shape like this onto the roller surface. So this is actually they're trying to show you over in this picture, is that if we take out, if we now cut the selenium paper and eventually make it flat out, we're going to see accumulation of toner ink like of this shape, because the original picture that we were trying to photocopy was also having T. So that's how the toner inks are going to get stuck over here. All the places where it is white, the toner ink will not get touched over here because those locations lost their charge. Beyond this point, surplus toner is removed. Surplus toner is removed because of one thing. Hey, let me show you something. Let's say here we have a table. We have a piece of magnet over here. It's a pretty strong magnet. If you let's say if you place a small object over here which is magnetic, this is gonna move. So এটা কিসের জন্য আঁকছিলাম জানো? ভুলে গেছি, দাঁড়াও। আচ্ছা, সারফেস টোনার ইজ রিমুভড। আচ্ছা, সারফেস টোনার ইজ রিমুভড এর যে আইডিয়াটা বলতেছি, মনে করো এটা হচ্ছে আমাদের পেজের একটা সারফেস। যখনই একটা আচ্ছা আমি তোমাকে ম্যাগনেট বলি, মনে করো এটা হচ্ছে একটা ম্যাগনেট। এই ম্যাগনেটের কাছাকাছি এই লোকেশনে যদি আরেকটা ম্যাগনেটিক অবজেক্ট রাখি, মনে করো আয়রন পেজ বা নেইল, then it gets attached over here. So you have one attached. Now if you continuously keep on attaching, what you're gonna have is gonna start producing a bump like that or a lump like that by attracting and capturing all the ions that it can, or all the opposite charged particles that it can receive. When this will happen, we are going to have a heap of toner material. So if this is the piece of page, this is actually highly magnified as well. If this is the page, this part used to be positively charged because no light fell onto here. The toners were neutral, so as they came close, they experienced we can actually spray negatively charged toner, or we can also send regular toner. The idea is that the toner will get stuck onto the roller in locations where we have what? Bolo? Someone? So we do not want this extra heap of toner to be existing on the piece of paper. We want the extra toner to be removed so that we have a very small thickness of paint or toner ink remaining on the paper, which will make sure that our after the printing is done, the toner will not actually make a splash out. So আমি যে তোমাদেরকে বুঝাই মনে করো বলবো না খেয়াল করো মনে করো এটা হচ্ছে পিস অফ পেপার ফিজিক্যাল একটা এক্সাম্পল বুঝো লেটস সে ইউ আর ওয়ার্কিং উইথ টিউব কালার তুমি যদি এখানে একটা টিউবকে জাস্ট টাচ করা সরায় নাও এবং এর উপরে এখান দিয়ে একটা রোলার একটা সিলিন্ডার চালায় দাও আলটিমেটলি কি হবে ওই লোকেশনটা ডট পড়বে ওই সিলিন্ডারে ফুল একটা সার্কামফারেন্স হিসাবে আরেকটা ডট পড়বে ওই আরেকটা সার্কামফারেন্স পর আবার আরেকটা ড্রপ পড়বে এভাবে কিন্তু ড্রপগুলো ক্রিয়েট হতে থাকবে ঠিক না অল্টারনেটলি যদি এরকম হয় যে আমি এখানে এত বড় একটা দলা একটা পেইন্ট রাখলাম আই কিপ এ ভেরি লার্জ অ্যামাউন্ট অফ পেইন্ট অ্যান্ড দেন আই টেক অ্যানাদার সিলিন্ডার অ্যান্ড দেন স্টার্ট টু রোল ওভার ইট is this lump of paint gonna be able to keep this beautiful circular shape or is it gonna become splashed in all sides whenever the roller will leave? What is gonna happen?
It's
Splash
flash.
all over.
It will definitely splash, and if it does splash then we are going to lose the beauty or the accuracy of the printing process. That's why we essentially have to remove the surplus toner from the page so that the printing is actually pretty beautiful. So here they have mentioned over surplus toner is removed. They haven't showed you any mechanical device. Surplus toner is usually removed using a mechanical device. It's just like a scraper. It scrapes off the excess paint which is not required, and then here and then we do this. Paper is pressed against the toner image to give image on paper. So now we're going to feed in the blank paper and we're going to roll this drum onto this piece of blank paper, and as we're going to roll, the ink particles, the toner particles which used to get stuck onto the piece of cylinder or the drum, that ink droplets are now going to get transferred to the piece of white paper that we are trying to print upon. So we took the image from T in one location, and now we are dropping the toner ink particles exactly in the same orientation on a similar page. Now it says number 6, paper is heated to melt toner image. This forms permanent image on paper. You have to understand that up to point number 5, we have dropped toner inks, which are powdered inks, onto the piece of paper. We have just dropped them, but practically they are not stuck there. I mean, if you blow them pretty hard or if you rub it with your finger, this tea is going to lose its characteristics. It's gonna the paints are gonna remove. We don't want that to happen. So what we do, we use some strong heat source over here. As a heat source, we are shown one light bulb. This can be any light bulb. This can be electrical heating. This can be any type of heating. But we're going to heat up the paper to a such high amount. We're going to do that to a such high amount that the toner ink particles, they're going to melt and they're going to get perfectly sit onto the container. So container also. So the paper is, I mean, all the writing of the using by the toner paint would actually stick in the position, and there wouldn't be any rough edges or smudge sides of this whole thing, because by scraping we made sure that we exactly have that much ink on the piece of paper, which is going to give us the best looking figure. So this is why scraping is so important, and once the toner is melted away, we just simply get a new plastic for the purpose. A new photocopy for this for the purpose that we wanted to achieve. এইটা হচ্ছে photocopy করার principal idea. I'll take our questions from you, but before I do that, I want all of you to have a look at these pictures and also read through this paragraph. এই পিকচারগুলো একটু দেখো, খেয়াল করো সবাই। প্যারাগ্রাফটি দেখা যাচ্ছে?
Yes, sir.
এই প্যারাগ্রাফটা একটু পড়ো সবাই। I'll give you 2 minutes and then we'll come back, or maybe better we're gonna keep this for I mean, we're gonna take the Maghrib prayer break right now. This is 6:31, so I'll be back by 6:45 ish because I need to make wuzu. So you say your prayers and come back and then read through this whole thing. And then if you have any questions about this thing, I will answer those questions after the Maghrib prayer break. ঠিক আছে, বুঝছো কি বলছি?
Yes, sir.
ঠিক আছে, we're taking a pause and we'll resume class shortly. So we still resume the class after the break. So one of the additional things that I'd like to say that this is how a photocopier works. Essentially, in the photocopier, we send light from the page that we want to print through a small aperture and eventually shine it onto the positively charged selenium roller. But what we do for the case of a laser printer, we do not essentially have original source. For a laser printer, a very sharp laser shines light onto this roller by a series of laser arrows. The reason we prefer to use laser is because laser light is such a light that it can go within a very straight line without deviation. It wouldn't spread out like a typical light source. I mean, if you have a regular light source, if you try to emit in a certain location, you will always see that it is spreading out by a certain amount. But laser doesn't do that. If you emit in a single location, it will keep that radius of that opening or as the source, no matter how far or close you get. It will not spread out. That's the whole beauty of laser. So we use very sharp lasers to do this discharging. So here you can see that all of these places where we had light reflected upon, those places become neutralized. And for the case of a laser printer, the whole thing is charged, and the places where you do not want the toner ink cartridge toner powder to get stuck, we discharge those things by shining laser upon those locations. And locations where you do not shine the laser remains charged, and that basically picks up the negatively charged toner particles, and which then scraped off to remove the surplus and then rolled over onto the paper, then heated so that it melts and gets stuck onto the paper. So that's the basic difference. In a laser printer, we do not use a source. We rather use the laser series of laser lights to do the light shining. That's why it can work from a computer order very easily. এই ডিফারেন্সটা কি বুঝা গেছে? বলমান laser printer তোমাদের সিলেবাসে নাই, but the idea of laser printer and photocopier is, in my opinion, essentially very close. Like they are, let's say, the first cousin of each other. So if any examiner in any of your say exam feels like they find the kids have learned about the photocopier, so they might or they might as well know about the laser printer as well. They can actually set some questions about that as well. So I feel comfortable to discuss this alongside this one as well. Any question?
Is there any reason behind the toner being a powder?
Advantage of having powder is that compared to, I mean, water molecules or liquid molecules tend to coalesce together, or they tend to join together. So they tend to form large size droplet naturally. Whereas if you think for physical particles, you can grind a physical solid object to a very small dimension. The advantage of having a powdered toner is that the particle size of that toner can be defined to have a very small size, much smaller than the droplet produced by an inkjet printer. So each of those toner can actually work as a small printing dot onto the paper, so that you have more crisp or more what can I say, more better looking or sharp edged printout by using toner particles, because their individual size is not as big as the drop size of an inkjet printer. So compared to that, these images can look far better in terms of borders and corners and straight lines. Does it make sense?
Yes, sir.
Good. The fourth thing is electrostatic precipitator. This is actually pretty simple. There is one specific thing where the students tend to lose mark even though they do know this answer, which I'll tell you at the close to the end. The idea is very simple. Pretty much like we filter liquid stuffs to strain unnecessary stuffs out. Industrial industrial chimneys or industrial burning processes produces a lot of pollutants which we do not want to enter into the atmosphere. So by law, in most countries, by law, they are required to have a filtration system of their exhaust chimneys from where the exhaust of their burning process comes out. So the way we can filter out or strain a gaseous medium, a composite gaseous medium, which has a lot of components within itself, is what is called a precipitator. A precipitator is basically a filtration system for a smoke or for a gas which is going upwards. We say electrostatic precipitator because we are going to use the idea of electrostatics for this purpose. The figure over here is actually very simplified. A lot of the parts are not shown, but I'm going to tell you this anyway. Here we have the smoke and the dust particles coming out. Smoke and the dust particles means the smoke essentially means that with the parts, the smoke is essentially what we want to get back to the atmosphere. For example, the smoke is made from carbon dioxide, sulfur dioxide, nitrogen dioxide, H2O, a little bit of oxygen, enough oxygen in nitrogen. All of these things, which are the atmospheric particles, even if by small amount, we can allow those things to enter into the atmosphere because they will be part of the individual cycle, carbon cycle, nitrogen cycle, oxygen cycle, blah, blah, blah. But things which are harmful for the environment, for example, let's say some large hydrocarbon molecules, unburnt fuels, or let's say the ashes of something. For example, if you think about ash, let me give an example. Whenever we burn methane gas in our stoves, we do not produce any residue. It just burns and it's just gone, right? But if you burn a piece of paper, after the entire burning process is done, you'd have some ash remaining. Now, what is that ash? I mean, we have burned the process, but we have some ash remaining which cannot be burned anymore. That is basically what is a dust particle. That is basically something that we do not want to be entered into the atmosphere. So whenever industrial chimney, industrial burner actually burns, it can burn a lot of stuffs. We do not want those solid particles to get into the atmosphere, and we only want the gaseous, actual gas particles to go out. So what we do, as the gas comes out, initially we put a metal mesh that is kept at a very high negative voltage. So let's say minus 50,000 volts. And as the total smoke and dust particles pass through here, all of these things, the smoke and dust particles, all of them, they smoke and negatively charged dust particles. Now here they have only said the negatively charged dust particles. They haven't mentioned that the smoke particles will also be negatively charged. There is a reason for this. Each of the smoke particles are considered to be part of the atmosphere particles, which means they are extremely small. They can also become negatively charged, but they will be very weakly attracted by what we have on top. What do we have on top? On top, we have charged particles are attracted to earth metal plate. You have to understand, this is not positive charge, this is earth. Very interesting. This is negatively charged, this is earth. You might wonder, why is this earth? Here's the thing. As this negatively charged dust, smoke and dust particles are going to slowly rise up, as they'll come close to this earth particle, which is essentially made from metal, this thing will become induced, and that induction will produce what kind of charge in this plate? Try to understand, the incoming particles are negatively charged. They're getting close to a metal plate over here. What will be the induced charge produced on this metal piece?
Positive.
Positive charge will be produced over here because this upgoing or incoming negatively charged the smoke and the dust particles, they are going to repel some of the electrons out of the plates into the earth. So this plate is going to become positively charged. Beautiful. And whenever we have opposite charges, they will attract, and because of this attraction, strong attractions will grab onto the large particles. Large particles in this case means that the dust particles are going to get stuck, and the smoke, basic smoke, that can go up with while remaining clean. You can see over here, smoke with dust particles removed. You can see over here that we still have the shadow over here, and some of the dust particles are still over there. You can see there are some dots remaining. Do you see that? Some dots are remaining. We cannot essentially filter 100% of the thing out. I mean, we can do that, but achieving 100% efficacy can prove to be really, really costly. So what we usually do, what the industrial chimneys actually do, they, other than having a single piece of plate over here, they can place multiple of these plates with a little bit of gap in between, not very close by, because a very close by would actually significantly lower the exhaust gas flow. So we can place multiple of these metal plates at certain gaps, earth metal plates. So each of them would do their individual attraction, and they will pick up more and more dust particles out of the exhaust gas. So we can have a much more cleaner environment. One of the advantage of having this place art is that whenever these negatively charged particles are gonna get attached and get attracted and get stuck over, attached and stuck with these metal plates, they're gonna give their extra electrons to these metal plates. Now, because these things are always art, those extra electrons can go back to the earth and remain this whole metal plate remaining at zero potential or remaining at earth, which will allow further induction process and more incoming dust particles can be attracted, because every single time this thing receives one or two or some electrons, all of those electrons are immediately sent back to earth because this is connected with the ground connection. Now, if it was not connected to the ground connection, if it was only just kept over here, after some time, after a very short amount of time, this will receive a lot of negatively charged dust particles, and this will become highly negatively charged, and then it will start to repel all the negatively charged particles which are coming towards it. So basically the filtration process would be unsuccessful. That's one advantage of having the art plate. One more additional thing that you need to understand, that over the duration of uses, if you, let's say you install this on a certain month's first day, and then you keep on using it over duration, as time will go by, these metal plates will slowly accumulate more and more thicker layer of dust particles, and that thickness of dust particles is going to work as a sort of like a barrier that will reduce the induction process. So every once in a while these things needs to be cleaned. They can be cleaned either by mechanically shaking them, or they can be physically cleaned by shutting off this chimney for some time, and then dropping some water, force water from the top, and basically washing them all together. So they can be cleaned in a lot of different ways, but they need to be cleaned every once in a while, and they will just work fine pretty well after. One of the thing that is important for you to understand, that in one of your questions in CIE questions, and one of the questions that happen to have the idea of a question from the electricity precipitator concept, what they say that what is charged in the process of passing through the metal mesh? I mean, what is charged? The answer to this question is both smoke and dust particles. You have to understand that. Have a look at the third heading from the bottom. Third heading from the top. There are 5 headings. So have a look at the very middle heading. It says what? Smoke and negatively charged dust particle. So you need to understand that both the smoke and the dust particles, they are all negatively charged. As the smoke particles are gonna get close to the earth metal plate, they're going to become neutralized, but they're not gonna get attached because they are so light that the push that is happening from the bottom is gonna push them out. But the dust particles being so heavy and being so large, as they will become discharged, they'll get stuck with these metal plates. You have to understand, as the whole thing coming from the very bottom of the tube, very bottom of the chimney, as the whole thing goes up, all of this thing becomes negatively charged, and only the large dust particles or ash particles or solid residues that they get stuck over here, but the basic gaseous molecules, carbon dioxide, sulfur dioxide, nitric oxide, nitrogen dioxide, or even H2O, steam molecules, oxygen, basic nitrogen, all of those things, they can actually pass through without any trouble. So it's important that you understand that all of these things are negatively charged over here, not only the dust particles, all of these things. Do I make sense so far?
So could you explain the gas part again?
What do you need to understand? The gas part of the atmosphere is basically what you cannot see, the colorless part, which is comprised of the molecules of various gaseous substances like nitrogen, oxygen, carbon dioxide, maybe a little bit of methane gas, because that's colorless. I mean, different about gases. And then we can have nitrogen dioxide, nitrogen dioxide, trioxide, and then we can have sulfur dioxide, this kind of stuffs. So these are the stuffs which can go into the atmosphere and eventually take part into the individual cycles, like nitrogen cycle, sulfur cycle, carbon cycle, oxygen cycle, water cycle, blah, 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 and eventually go on their pathway. So that's not a big deal. But if we allow all the solid residues, like the ash that remains after burning some paper, if we allow all of those things into the atmosphere, this is going to cause some serious havoc in terms of pollution. So that's what we do not want to get out. Smoke essentially means the atmosphere merged with invisible new particles. Dust means visible new particles.
I was asking about why doesn't the dust particles get attracted to the metal plate
And get stuck over there because of the heavy mass, or because of the heavy weight. Once they become attracted over here, they slow down and they pretty much get stuck over there. is just because of electrostatic attraction.
Yes, sir.
বুঝছো কি?
স্যার এখনো বুঝি না গ্যাসটা কেন অ্যাট্রাক্ট হয় না
গ্যাসটা অ্যাট্রাক্টেড হয়, বলতেছি গ্যাসটা অ্যাট্রাক্টেড হয়। আচ্ছা আমি তোমাকে let me give you a very simple example. Try to hear me out. Let's say let me think of it here. Okay, let's say you have let me think of a good example that can make sense with you. Okay, somewhat came out of it. Try to think about it. Let's say you have one of these chamber. Let's say disregard the charging effect for the time being. Disregard the charging effect. Let's say you have one of these thing and forget about this metal mesh. Let's say you have placed one small piece of cotton at the bottom, and also another balloon that is slightly filled up with water, so that it is not as light as air. It is some significant mass compared to the cotton. Do you get my point? The balloon is definitely larger in volume, right?
Yes, sir.
Let's say that balloon is okay. Now we are sending in high pressure gas through here, so both the piece of cotton and also the balloon, they're going to start rising up. Once they reach up over here, what will happen to the cotton? The cotton get heat in a lot of different places. The moment it gets heat, it will discharge itself. But because it is so light, it doesn't have to get stuck. It can go left and right, and ultimately it will find one of these holes and it will go out because there is a continuous pressure from the bottom. But what will happen to the balloon? As the balloon comes up, it will get stuck over here, and because of its heavy mass, it is possible that it might not, and because of its large, it's possible that it's not going to be able to pass through, because once it hits one of these plates, it is going to decelerate, right?
Yes, sir.
Because as the chimney gas slowly goes up, what essentially happens? The pressure of the chimney slowly becomes less. So you have a more high temperature at the bottom close to the furnace, and as the slowly it goes up, it expands in volume, obviously, and slowly the temperature goes lower, which means you are losing a significant portion of your energy. And when these particles actually lose a significant part of the energy, they don't have enough energy to go upwards anymore. And we are essentially actuating this process, or we are accelerating this process by placing some physical barriers over here. Did this example make any sense? Like help?
Yes, sir, it did. It did, sir.
Sure. Any further question? Anyone? Okay, I want all of you to read these three things. I'll explain this thing. I'll talk about this thing in a bit, but everyone, please have a read over this one.
Sir,
All right. So about the first bullet, what did you understand?
Planes get charged.
When dissimilar things get rubbed against each other, they can become charged. Good. So aircraft flying through air, vehicle going through on road, so they can build up static electricity within themselves. So if before any sort of refueling, they must be discharged first, because if they are not discharged, there can be a series of events which can lead to catastrophe. It is important that you be able to write those series of events in a consecutive manner, not left and right or haphazard hodgepodge manner. So this is what can happen. If an aircraft or also a truck or full tankers or transport fuels, if those things are not earned before any refueling, you have to understand that fuels in many cases / in most cases can be extremely flammable. And many of the fuels, for example petrol and anything that goes higher, octane as well, they are also volatile. Volatile means that you have some open fuel, liquid fuel, visible liquid fuel, naturally they will evaporate at a much really fast rate and produce a fuel air mixture on top of the fuel, which you cannot see. So even a slight bit of hot object entering into this thing, which can actually make those things reach to their ignition point, which we talked about in our thermal class, can start a fire, which will lead on to subsequent firing of the neighboring molecules, and all of this thing will work like a domino effect or a cascading effect, and eventually you can have a large fire, which in other words can say to be an explosion. So this is how it can work. Dissimilar objects rubbing against each other, for example aircraft going through atmosphere or a fuel tanker going across the road for a significant duration, can build up charges within their body. Before any refueling, they must be discharged to avoid any spark creation. If it is not done, then when the when the refueling nozzle is brought close to the vehicle or the aeroplane, opposite charges will try to neutralize each other. You have to understand that that the nozzle is usually always kept earth. So I mean, let me just show you one of the refilling nozzle. It might actually help you understand better. No, almost. No.
Sir,
Yes.
sir, it's a off-topic thing, but class 10 এর রুটিনটা কি ডিসকাস করা যাবে?
জি স্যার।
Do we have to change?
স্যার আপনি বলছিলেন স্যার যে আপনি এখনই রুটিন ফলো করবেন, স্যার এটা কি করবেন অ্যাকচুয়ালি?
That's precisely my expectation. If you all agree.
মানডেটা তো চেঞ্জ করতে হবে স্যার।
Like, do we have to?
9:30 থেকে না?
হ্যাঁ।
স্যার সমস্যাটা হলো কি স্যার, আপনারটা চেঞ্জ না হলেও স্যার অনেকগুলো চেঞ্জ হয়ে যাচ্ছে, তো তার জন্য এটা সমস্যা হতে পারে।
Well, 9:30 is, I think, a pretty late timing. I mean, unless really someone really want to overlap me for half an hour, like someone takes class, let's say 10 a.m., then it's unlikely that this timing will be affected. I personally do not want to change class 10 timings. I want to keep them as is. Only the Ramadan timing is discussed, so Ramadan timing will be different because of Ramadan. That's one thing. But other things would be, I mean, the regular class timing, I plan to keep it as is. Unless this gets affected by other routines, I'm not inclined to change it.
স্যার আমার টিউসডেটা ক্ল্যাশ করছে।
কটা থেকে কয়টা?
টিউসডে আমার 3টা থেকে প্রায় রাত 11টার সময় পর্যন্ত আছে।
আচ্ছা, আমার টাইমিংটাতে এক্সিডি কার ক্লাস পড়ছে?
স্যার আমার 4:30 থেকে 6:30 টাইমটা একটু ফ্রি আছে। 6:30 থেকে 8:30 পর্যন্ত তুলান স্যারের পরপর 2টা ক্লাস আছে।
আচ্ছা, তুলান স্যারের কারেন্ট টাইমিং কি এই দিন না মানে ক্লাস 10 উঠার পর তার টাইমিং চেঞ্জ হয়ে যাচ্ছে?
ও আচ্ছা, হ্যাঁ স্যার, তুলান স্যার এখনই টাইমিংটা রাখবে। ও হ্যাঁ, তাহলে ঠিক আছে, আমার ক্লাস করছে না, সরি।
ওকে, তাহলে তো সমস্যা নাই।
আচ্ছা স্যার, আমার মানডেতে না সমস্যা হচ্ছে স্যার। অ্যাকচুয়ালি মানডেতে আমার ক্লাস করতেছে, মানে এই রামাদান টাইমিং।
অলরেডি?
ইয়েস স্যার।
বলো কি করতে পারি?
স্যার একটু ইয়া লেট, মানে আর একটু টাইমটা যদি একটু পিছায় দেওয়া যায় যদি সম্ভব হয়।
মানডে টাইমটা কটার সময় ছিল?
স্যার 3টা থেকে 4:30 ছিল।
এখান থেকে আরো পিছাই দেবো, একটু পিছাই দেবো, কারণ তোমার কি এক্স্যাক্টলি এই স্লটে ক্লাস পড়ছে?
স্যার আমার পারভেজ স্যারের ক্লাস পড়তেছে।
কোথা থেকে?
মানডেতে আমার পারভেজ স্যারের কেমিস্ট্রি ক্লাসটা।
ও
এক্স্যাক্টলি
স্যার,
বলো।
মানডেতে আমাদের স্কুলের কাছে 1:10 শেষ, so আপনি ওই গ্যাপে নিতে পারবেন।
মানে মানডে তো 1:30 থেকে 3টা বলতেছো?
মানডেতে আপনি 1:10 পর নিতে পারবেন, কারণ আমাদের সবাই স্কুল শেষ তো।
স্কুল শেষ
আমাদের
হওয়ার পর?
স্কুল শেষের টাইমটা স্যার, আমাদের স্কুল শেষের টাইমটা স্যার আগায় দিছে স্যার, মানে 1:10 করছে, 1:30 বা 1:10 সামথিং।
তাহলে মানডে তো আমরা 1:30 থেকে 3 পর্যন্ত নিতে পারি। প্রফেসর ক্লাস কটা থেকে?
স্যার পারভেজ স্যারও বলতেছে কি স্যার, পারভেজ স্যার অ্যাকচুয়ালি স্যার 3টার দিকে, কিন্তু পারভেজ স্যার বলতেছে যে আমি আধা ঘন্টা আগাইতে পারি, আমি আধা ঘন্টা আগের থেকে শুরু করতে পারি, তো ক্লাস করতে পারি আই গেস। পারভেজ স্যার ঠিকমতো বলে নাই যে আমি আধা ঘন্টা আগে শুরু করবে নাকি না, বলছে ইনফর্ম করবে যদি করে।
তাহলে
আমি
আমি তাহলে আমি
সেকেন্ড ক্লাস কেমিস্ট্রিতে।
বুঝি নাই।
সেকেন্ড ক্লাস স্যার, 2টা ক্লাস না পর পর?
হ্যাঁ আমি তো প্রথম ক্লাসটা করি 3টা।
হ্যাঁ, তো লাইক একটু অ্যাডজাস্ট করতে পারবে না সেকেন্ড ক্লাসের জন্য?
না আমার, না আমি সম্ভব না, কারণ আমার পরে ক্লাসটা পারবো না, কারণ আমার ম্যাথস ক্লাস আছে রাত্রে, বিজ্ঞান।
আচ্ছা শুনো, আমি বলতেছি, জানেন পজিশন এন্ড সামি থ্যাঙ্ক ফর রিমেম্বারিং ইওর প্রবলেম। একটা জিনিস হচ্ছে, পারভেজ স্যারকে একটা জিনিস বলো যে এই টাইমিংটাতে সাফারা স্যার ক্লাস দিছিলেন, আর স্যার যদি এক্স্যাক্টলি 3টা থেকে 4:30 রাখেন, তাহলে আমি হচ্ছে আগের টাইমিংটাতে শিফট করে ফেলবো, 1:30 থেকে 3টা পর্যন্ত আমি ফিক্স করে ফেলবো, সো দ্যাট নান অফ আস গেট ইন এ ক্লাস। এটা একটু স্যারকে বইলো ক্লাসের পরে বা শেষে, ঠিক আছে? যদি স্যার এগ্রি করে 3টা ফিক্স করে দেয়, তাহলে তো ঝামেলা শেষ হয়ে গেল, মানে দ্য ডিসকাশন ইজ ওভার। আর তারপর যদি স্যার বলে না, তারপর আমার আধা ঘন্টা পিছানোর সময় আছে, সেই ক্ষেত্রে আমার কিছু বলার নাই, বিকজ আই এম ট্রাইং টু বি অ্যাজ অ্যাকোমোডেটিং অ্যাজ পসিবল। এর চেয়ে বেশি আর কি করতে পারি?
জি স্যার, আমি বুঝতে পারতেছি স্যার, না আমি পারভেজ স্যারকে বলবো, সমস্যা নেই।
ঠিক আছে, স্যারকে একটু বললো যে ওরকম হলে তাহলে আমি 1:30 থেকে 3টা স্লটটা আমি নিয়ে নিলাম, স্যার ওই থেকে 3টা থেকে শুরু করলেন, তাহলে আর কোনো ঝামেলা থাকলো না আর কি, এটাই।
হ্যাঁ জি স্যার, এটা চলবে স্যার,
ঠিক
সমস্যা
আছে,
নেই।
বিউটিফুল। আচ্ছা, লেটস গেট ব্যাক। সো এটা হচ্ছে টিপিক্যাল রিফিলিং নজল, দেখতে হচ্ছে এরকম। রিফিলিং নজল গুলো দেখতে এরকম হওয়ার কারণ হচ্ছে যে এখানে দেখো একটা this is usually made from metal and we have the gun over here and usually it has a lot of parts over here. আমি অ্যাকচুয়ালি যে জিনিসটা দেখানোর জন্য তোমাদেরকে নিতেছি সেই জিনিসটা আমি এখানে দেখতেছি না। আচ্ছা হ্যাঁ, বলতেছি the way a refilling nozzle works is that whenever we press this thing, a lot of things happen simultaneously. একটা জিনিস খেয়াল করো, এখানে ফার্স্টে when we press the lever, this thing is pushed up and then this thing is pushed down. So the fuel practically travels through here, fills up this chamber, then goes up over here, and then only it comes up. So there are actually basically 2 different pathways to be opened. Now এটা কেন ইম্পর্টেন্ট? এটা এই জন্য ইম্পর্টেন্ট যে এই যে রিফিলিং সবগুলো রিফিলিং ক্যানে দেখো যে এখানে একটা স্প্রিং লাগানো আছে না, এক্সট্রা একটা স্প্রিং দেখতেছো না সবগুলোর সামনে, এই যে এরকম স্প্রিং। This spring is actually connected with a certain earthware that runs through this entire channel. এই যে এখানে পুরো একটা ফুল কেবল যদি দেখায়, এই যে পুরো কেবলটা দেখতেছো না, এই পুরো কেবলের ভেতর দিয়ে there is a metal mesh that runs through this entire cable that goes all the way up to the point which is grounded at its bottom. The idea is that a person is supposed to push this thing all the way into their chamber, so that this spring would make contact, spring or even the top. The spring is usually connected with the earthware, and everything would, this would touch the car body. The car body would immediately become neutral, because it's not going to take a lot of time, because this is a pretty thick conductor. And the moment the person actually starts pressing their handle, by this time their car is already earthed. So it is designed in such a way that the earthing will happen unavoidably, which is good, because we work with dumb people in the world quite often. So that's why they're built-in design is such there, so that we can avoid avoid any type of accident. The problem of statistics, মানে এই কোশ্চেন আনসার লেখার সময় স্টুডেন্টদের যে প্রবলেমটা হয়, the problem the kids face is that sometimes they mess up the sequence. The sequence of accident is like this: if the vehicle slash airplane is not earthed before refueling, whenever opposite charges will get closer, there is a possibility of spark. This is a keyword. Spark is a keyword. Do you guys understand what a spark is?
Lightning.
It's a small scale lightning. Beautiful. I was looking for this exact word. It's a small scale lightning. What happens in the case of lightning? In the case of lightning, large amount of voltage gets created between the earth and the clouds, and electrons move through atmospheric particles, producing lightning. Spark is the same thing. Whenever a significant high voltage is created across two bodies which are kept a bit distance far apart from each other, as they are brought closer, the electric field slowly becomes stronger and stronger. And there can happen to be such a distance, depending upon the voltage of the two objects, that the electrons would be able to make a jump through the atmospheric particles, pretty much like the lightning. Whenever they'll do that, they will heat up that in between space through which they are jumping, in between atmosphere through which they're jumping, they'll heat up that atmosphere. It is basically as if the atmosphere is working for a small conductor for a very small duration of time, but because it has a very high resistance, it heats up a lot. So some electron will jump from the low voltage end and to the positive voltage, negative voltage to the positive voltage end, and in this process they will produce a spark. This is a spark is a keyword. So I'm starting again. If the aeroplane slash vehicle are not discharged before refueling, it is possible when two opposite charge bodies are gonna brought closer, there will be a spark, comma, which might ignite the fuel and air mixture. Fuel itself cannot burn. You need to have air present as well. Whenever fuel and air gets mixed together, that's basically what is explosive. Fuel itself without the presence of oxygen, not explosive. Oxygen itself without the presence of fuel, not explosive. Combination, explosive. So which a spark can create it, which can ignite the air fuel mixture, that might lead to an explosion. এখানে প্রত্যেকটা কথাতে মে মাইট কুড লেখা আছে, কারণ হচ্ছে স্পার্ক যে হবে তার গ্যারান্টি নাই, স্পার্ক হলেই যে ইগনিশন হবে তারও গ্যারান্টি নাই, ইগনিশন হলেই যে এক্সপ্লোশন হবে তার গ্যারান্টি নাই। ইট ইজ পসিবল ফর some rare cases where all of these three things can become yes, and we can actually have a big catastrophe, which we don't want to happen, but these are all bound by probabilities, not certainty. Do you understand my point?
Yes, sir.
এই জিনিসটা বুঝা গেছে যে লিখতে হবে কিভাবে? If they are not earthed slash discharged before refueling, whenever oppositely charged bodies are gonna brought close together, electrons may jump through air, producing a spark. I used the word may, producing a spark, comma, which might ignite the fuel air mixture, comma, might lead into a explosion. সো কমা কমা দিয়ে লিখলে লেখা অনেক ইজি হবে, তোমরা জাস্ট নরমালি জিরান বা পার্টিসিপল করে লিখে ফেলতে পারবে। আর যদি ফুল সেন্টেন্স লিখতে যাও তাহলে প্র্যাকটিক্যালি লেখা অনেক বড় হয়, এবং ফুল সেন্টেন্স কখনোই লেখার প্রয়োজন নাই। Number 2 and number 3 are actually pretty simple. If any of you don't have any question about these two, I do not want to discuss about them. I think this makes sense.
So I have a question about the first point.
Yes.
When the charge develops on the aircraft, how big is the potential difference? How big can we expect it to be?
How big the potential difference can become?
Yes, sir.
I'm not actually familiar with the exact values of this sort, but I can definitely Google that. But what I do understand is the amount of voltage has a maximum value. It has a maximum value because one of the things that, I mean, try to understand one thing. Whenever I was discussing the idea of charging process, I talked to you about ionization process and the periodic table and all those things. What I was trying to give you insert in your mind is that it is very, for some materials, it might be very easy to steal one electron. Stealing the second one might be difficult. Stealing the third one might be more difficult. Will be more difficult. Stealing the fourth one will be even more difficult. Okay, so as an aircraft become more and more charged, it will become less likely to become more charged. So essentially, by the size of the airplane and by how much metal cover does it has, there is definitely a certain upper limit, upper bound, what I believe, by after which the airplane body will not become charged. But considering the entire size of an airplane, the entire fuselage and all the metal body and everything it has, the amount of charge that one airplane can build up within itself is really good enough to produce some significantly powerful sparks, if not discharged properly. But I'm not familiar with the exact number that how much voltage could possibly be created. I don't know this.
So if you were to earth the airplane with our hand, we would actually get a really big shock from it.
Yes, and this is also one of the things. I mean, if for those of you who have actually taken a flight anywhere, you would see that whenever a flight lands, usually the doors are not open immediately. The airplane taxis to the runway, then it stops and stands still on the runway for some time. Then, if it is supposed to be connected to the terminal, then if it actually rests on the runway for some time, then it starts once again and slowly moves to the terminal, and then it gets connected to the terminal hatch, and then after some time they open those doors. Within this duration of movement and waiting, at some point, at a certain point, some ground technician connects some strong electrical earthwires carefully to the entire airplane body, so the whole airplane body is practically discharged, and only then the doors are open. There's a very good reason for this. If the airplane body is not discharged before the doors are open, any person, maybe the air hostesses or the pilot or even the passengers who are coming out of the airplane body, if they by some mistake even touches the metal body of the airplane, they themselves might get a big shock at that point, which for weak-hearted people might lead to heart attack and other type of problems. So even for human safety, if it's not even not for deadly, even for the sake of not giving the patient customers discomfort, they will discharge it immediately as early as they can, and only then they will allow the boarders to leave off the plane. That was a bit far-fetched, but I think I made my point.
Yes, sir.
So that's pretty much it for the static electricity chapter, and it took almost 2 full classes, which I didn't expect it to, but I tried to go at length. আচ্ছা, আমি তোমাদেরকে একটা জিনিস বলি, কালকে থেকে তো রমজান শুরু, কালকে কি আমরা দেড়টা একটা এক্সট্রা ক্লাস নিতে পারি? কারণ আমি গতকালকে ক্লাস নিতে পারি না, বিকজ I honestly forgot about your class and I was busy cooking. আমার 11:30 দিয়ে খেয়াল হয়েছে যে তোমাদের আজকে ক্লাস থাকতে পারে, পরে আমি মেসেঞ্জারে ঢুকে দেখি যে 11:30 বাজে, সো আই রিয়েলি ফেল্ট শিরি আফটার ইট। কালকে তো মানে আজকে যাদের সেরি খেতে কালকে থেকে রমজান শুরু, তাই না?
Yes, sir.
আচ্ছা,
Yes, sir.